Okay, today is lesson 4.7, graphing linear functions, and our learning target is going to be I can graph linear functions. So as you can see, this format is what we've been used to so far with our graphing. Now in this section, we are going to start naming our functions. So when we name our functions, we have a new vocabulary word. It's called function notation. And function notation simply turns at y equals mx plus b, and it changes it. Instead of y, we're going to write f of x. So again, that's just notation. It's another way to write the variable y. So the symbol f of x is another name for y, and it is read as the value of f at x or simply as f of x. It does not mean that you're going to do f times x. And you can use other letters instead of F. You can use G, H. An example down below, you see D. It's just simply a way to name your equation. So if you look below, we're going to try a couple of these examples. In example 1 here, we're going to evaluate the function when x equals -3, 0, and 2. So that means I have to do 3 separate problems. So I'm going to zoom in because I'm writing on the iPad and it's a little difficult. But you are going to need to try and write small so you can fit all 3 of these examples in the space that you have provided. I'm going to try and make this straight. Okay, so the very first one I'm going to do is x equals -3. So what that means is that wherever I see an x in that example, I'm going to write the number -3. So I have f of -3 equals 10 times -3 plus 3. And I'm going to complete this vertically then. So I have -30 plus 3, which equals -27. So this means that f of -3 equals 27 is my solution. And if I were to write that as an ordered pair, my x value is -3 and your y value is -27. So this would be your ordered pair. The next one I have to do is x equals 0. So again, wherever I see an x, I'm going to write the number 0. So f of 0 equals 10 times 0 plus 3. And I'm going to complete this vertically. So 10 times 0 is awesome because it just cancels out. And I'm left with 3. So as you can see on the left there, all I'm doing is carrying down that notation. I'm not multiplying anything. I'm just carrying it down. So that would be my solution. And then my ordered pair, if I had to plot this point, my x-coordinate is 0 and my y-coordinate is 3. Then the very last one we have to do is x equals a +2. So again, wherever I see an x, I'm going to write +2. So f of 2 equals 10 times 2 plus 3. 10 times 2 is 20, and then plus 3. So my final answer is f of 2 equals 23, which is my solution when I have to evaluate. And my ordered pair, if I had to graph this, my ordered pair would be 2, 23. Oh, and I forgot my other bracket there. Okay, so if that was written a little too fast for you and you want some extra time to write that down, please pause the video right now, write this down, and then when you resume it, it is going to be erased, and then you can save some room for your next example. So if you need some extra time, pause it, write down the example, and then resume the video. Wow, this eraser takes forever.
It's not a very big eraser.
No. At least I'm using Christmas colors. Good enough.
Okay, now we're gonna do the next problem. And again, we're gonna use those same numbers. So when x equals -3, I'm gonna plug that in for x. So h of -3 equals -2 times -3 plus 11. So h of -3 equals a -2 times a -3 is a +6 plus 11. So h of -3 equals 17. And then just like Miss Zarnes was saying, if I wanted to write that as an ordered pair so I could plot that point, you would have the ordered pair -3, 17. And I'll try and write a little smaller here because that erasing was kind of annoying there. So then the next one here, when x equals 0, 0 is my favorite one. It tends to be a little faster. So h of 0 equals -2 times 0 plus 11. -2 times 0 is just 0. So h of 0 equals 11. And again, we are challenging you to use that notation, that function notation. So make sure that you are writing h of 0 equals 11. And then that last point that I need to do is when x equals 2. So when x equals 2, everywhere that I see an x, I'm going to plug in a 2. So -2 times 2 plus 11. So h of 2 equals -2 times a +2 is a -4 plus 11. Oh man, here we have to go back to chapter 2. A -4 plus 11. Hopefully you all have calculators. You can use those now. Otherwise, hopefully you remember is 7. So h of 2 equals 7. And again, if you want to write that as an ordered pair, it would be 2, 7. So what we'd like you to do now is pause the video, oops, and write this problem down. And then what we'd like you to do is try this problem on your own. So please pause the video now and try this problem.
Okay, at this time, check your work. Hopefully you've gotten them all correct. And then we will move on to the next example. Okay, in example 2, we're going to find the value of x so that the function has the given value. So right after that semicolon, I'm going to zoom in to just that first example. The given value that they're talking about is this number after that semicolon. So what you're going to do is take that given value and you are going to replace this whole thing with your given value. Because right now you want to try and find out what x value is going to create that. So we're going to write 7 equals 3x minus 2. And now this brings us all the way back to chapter 3. And we're going to draw our line and solve. So we're going to add 2 first. So we have 9 equals 3x, and our 2's cancel out. Divide both sides by 3, and you're left with 3 equals x. So our x value is a positive 3.
Okay, so moving over, we're going to look at that second example there. So this is g of x equals -x plus 1. And then after that semicolon is the number 1. Something that I think is helpful for students is to put kind of an imaginary, sorry that wasn't the best there, but kind of stick a 1 in front of that x just to kind of help remind yourself that that is a -1. But you're going to take 1 and you are going to plug it in for the whole thing, all g of x. So you're going to have 1 equals negative 1x. If you don't have the negative 1, that's fine. Plus 8. Draw your line down and do your order of operations backwards. So I'm going to subtract 8 from both sides. 1 minus. Okay, so that equals negative 7. Oops. And then the positive 8 and the negative 8 cancel, so I'm left with a negative 1x. And again, if you just left that as negative 1, that's fine. But do be aware that x is not by itself yet. You do need to divide both sides by negative 1. So a negative 7 divided by a negative 1 is 7, so x equals 7. And if you wanted to write ordered pairs for this, it would be 7, 1. So they're giving you, this 1 is really like your y value, if you will. What we want you to do now is, hopefully we caught this mistake on your printout, so hopefully it's not there. But this is actually number 3, not number 34. So hopefully that's changed on yours. But what we'd like you to do now is pause the video, try this problem, and make sure that you can do this on your own. So when you have a quiz and the test, you're all set to go. Okay, so here is our work for example 3. We ended up getting x equals 2. We're going to kind of switch gears here a little bit and look at another example. So here are all 3 examples. Okay, so now we are on the second page of your packet, I believe. And ours is nice and in color. Yours might not be, so maybe if you have some colored pencils or something, you may want to take those out right now. But what we're going to talk about is comparing graphs of linear functions. So starting out here, when you change m or b in general, the linear function is going to adjust or be a little different. So looking at this first example here, unfortunately I don't have a blue, but we have this thing called a parent function. In the parent function is this line, oops, and yours is going to be straight, is the graph of the function f of x equaling x. Or if you really don't like function notation, that's the same thing as y equaling x. So you're just going to kind of go up 1 over 1. If you notice, you're just kind of going through all these points right here, or you should be with your ruler if you used one, or you should use one. But then, not all of our equations are going to be like that. Some of them are going to look like this equation here, g of x equals x plus b. And b is just representing a different number. So when I add or subtract a b, it's going to shift my graph either up, like this top one here, or down. I don't know if I can make, oh I can, here we go. I can make my line a little thicker here so you can see it. So this one right here, this is me shifting my graph up. This other equation down here is me shifting my equation down. So we say that this is a vertical translation, or that's the mathematical words that they use. If you read that paragraph below there, they talk about vertical translations. And then if we look here,
How do you know if it shifts up?
so if you are adding a number, I don't know how much we want to write here on this. If you are adding a number to x, it's going to shift up. So like f of x equals x plus 2 is going to be shifted up because you are adding 2. If you subtract, so like f of x equals x minus 3, I'm subtracting 3, so that's going to shift it down. So really the only difference is I'm subtracting 3 on this one and I'm adding 2 on this one. There's some other things you can also do with your graphs here. You can do what the book calls stretching and shrinking your graphs. And this can get a little complicated, so I'll do my best to explain it. So first thing we've got here is this parent function again. It's in blue. And so what I'm actually going to suggest that we do at this point is we're going to move down and look at our example 3 and graph our parent functions right now on those two graphs. So move down. Hopefully you've got all of this right in front of you. You don't need to move your paper around like I do here. But I'm going to do my parent function in one color, and I'm going to do my best here with my iPad here. But when you graph your parent function, it always starts at the origin. So that's your point 0, 0. And then if you remember, your parent function is y equals x. So when x is 1, what does y need to be? It needs to be 1. So if I make a table here, so if x is 1, my y is 1. If x is 2, what's y? You guessed it, 2. And then if x is 3, y is 3, right? So you're just going to kind of go up a box and over a box each time, and I'm going to do my best here. And that's your parent function. And I'm going to do the same thing over here. Start at the origin, plot the points, and then you can kind of see the pattern. And you should be using a ruler, not having squiggly lines there. I'm going to erase this just so we have a little more space. But so that's your parent function. That is y equals x, and this is y equals x. Now, going back up here and looking at this example here where it talks about stretching and shrinking. So stretching a graph is going to be when so this is what it's going to look like when you stretch it right here, the red line here. Stretching, let's see how well I can do here. Stretching is when the number in front of x, so if you look up here, the number in front of x is greater than 1. Now, you may be asking yourself, well, what happens if it is less than 1? Well, this gets a little tricky here, but it shrinks, and it's not just if it's less than 1. It shrinks when it's a number between 0 and 1. So you're looking at a bunch of fractions and decimals, but that make it shrink. So stretching is when the number in front of x right here is greater than 1. So for example, this one could have been g of x equals 2x, right? Because 2 is the number in front of x and it is larger than 1. This other graph here could have been g of x equaling 1/2 x, because 1/2 is between 0 and 1. So that is shrinking and stretching. Now looking here at the next little part here, we're going to talk about how you ever get a graph that goes the other direction. So again, here we've got our parent function, right? So that is your g of x equaling x. And then what happens if the number in front of x is negative? It's actually going to flip it. So here are two examples of your graphs flipped. So for example, this one could have been g of x equaling negative 3x, right? Because that number in front of x is negative, it is less than 0, so it would flip it. Now, you kind of have to be careful here and put a few things together. If you have a negative number, so like you would have had g of x equaling negative 1/3 x, not only would your graph be flipped, it would also shrink. So you do need to be able to put some of these thoughts or ideas together. So we're going to look at example 3 now, and I'll pass it over to Ms. Zarnes, and maybe she'll explain it slightly different than I am, and that will make a little more sense to you. And she might be a little pickier. That second graph there, that's not a very straight parent function. But she's going to start looking at number 1.
Okay, in example 3, we need to graph each of these functions and then compare your graph with the parent function. So, to graph this first one, g of x equals 8x, think of that as the same thing as y equals 8x. So when I create this table, so I'm going to complete this table. I'm going to pick a few values. I'm just going to pick a negative number, 0, and a positive number, so I can kind of see what's happening to this line on either side. So negative 1 times 8 is negative 8. 8 times 0 is 0, and 8 times 1 is a positive 8. And as you can see, if I'm going to plot this, my negative 1, negative 8 ordered pair is not going to fit on this graph. So I'm going to move to the next one. So I have 0, 0. And then I have a positive 1x and 8. And then again, I'm going to try my best to try and connect these two. See if I can find a straight edge. And I'm going to connect these two and create my new line. Oh, let's try that one more time. But as I'm drawing this, you can already see that that line is stretching. So this number in front of x is precisely what Miss Olson was talking about. That number is greater than 1. So it's bigger than 1. So it's stretching my parent function, and it's making it taller. If we look at that next example, g of x equals x plus 4. Again, if you don't like the function notation, you can think of this as y equals x plus 4. And we've been graphing these for a couple weeks now. So if I make my table, and again, I'm going to pick a negative, 0, and a positive, and plug each of those in. So I have negative 1 plus 4 is 3, 0 plus 4 is 4, and 1 plus 4 is 5. Each of those are my ordered pairs I'm going to plot. So I have negative 1, positive 3, 0, and then positive 4, and then a positive 1 and 5. And again, I'm going to try my best to connect these as straight as possible. That looks way better.
Better than mine.
Way better. And so as you can see, this equation up here tells me how my graph is going to shift from that parent function. So from Miss Olson's squiggly parent function, we're shifting, every single point is shifting up 4 units. So as you can see, this would have went up 4 units. Or this point right here is shifting up 4 units. So we can already tell what the graph is going to look like before you even graph it, based on the parent function and the numbers around it. So if you're adding something or subtracting something on the end, you are going to shift it up or down. And if I look back at that first example we did, if that number before your x is bigger than 1, it's going to stretch it. So what I would like you to do now is to pause the video, complete that next example on your own. You're going to be just matching. So which equation matches with A, B, and C based on what the equations will look like. And if you need to, write down the parent function and compare, and then start the video and check your answers. Okay, so at this time, check that you have gotten this correct. You should have 1 matches with C, 2 matches with A, 3 matches with B, and I circled in red or boxed in red each of the pieces that told me what matches. So number 1 matches with C because it's a vertical stretch. Number 2 matches with A because it shifts up. And number 3 matches with B because it shifts down. So at this time, you can pause your video, come with questions tomorrow. If you want to make sure you remember them, maybe write them down in your note packet, and then just be ready to do your practice.